So, good morning or good afternoon. Happy Holi today. And for those of you who don't know me, my name is Rachit Verma, and I'm a PhD student at IIT Dharwad. I will be holding this week's problem session on the notes that have been discussed on the material that has been discussed for week 5. So, in week 5 we had so in week 5 we had we had gone over two major areas. One is deep reinforcement learning for cloud edge, and then we had discussed public cloud services, uh, and for more specifically that of AWS. So uh, I'll just summarize what was discussed. So we had discussed how collaborative cloud edge approaches can provide better performance and efficiency, and then we had discussed how about some resource allocation strategies that can be tailored to some specific use cases. So we had already seen quite a lot of this material even in previous lectures, or some combination of it. Then saw some basic differences between the public and the private cloud environment. So, and then after that we saw like a basic formulation about how a number of VMs could be requested, about how and their computing time duration, and how a lot of them could be stored in an allocation record. And then after that we had seen a basic formulation about how at a new time instance you could see uh, how every new time instance some cost was computed, and how at every new time instant VMs were computed. Then we saw this demarcation in the public and the private cloud. Just a second. And then after that we saw some resource allocation algorithms. First is we formulated our resource allocation scenario as a Markov decision process, and as a parameterized Markov decision process. Then we saw how DDPG, or the deep deterministic policy gradient, could be used to um, could be used to solve the scenario, or could be used to address the scenario. Then we saw how PDQNs could be used. We saw resource allocation based on PDQN. We uh, we then saw the cost efficient resource allocation in public. We saw cost efficient resource allocation in the public cloud. And then after that we saw a simple problem. We saw a basic problem, and then we specifically saw AWS. Okay, and in AWS we saw the various layers of AWS, and we saw a basic overview of the global infrastructure of AWS. So how it was divided into regions, availability zones, and edge locations. And then we discussed its global footprint. We saw how many countries AWS has some sort of infrastructure in. Then we saw we saw the concept of regions and availability zones, and the contents of what is present in each region, and how availability zones can be linked to each other. We saw the uses of, as in how helpful these availability zones were. We saw that every region has multiple isolated locations known as availability zones, and then every availability zones has data centers. And we saw that a data center cannot be present in more than uh, each data center cannot be present in more than one availability zone. And then we discussed the various layers of security in Amazon Web Services. We saw that we saw the portions of the security that AWS is responsible for. We then saw the portions of security that the customer that is using AWS is responsible for. We saw the concept of the virtual private cloud, as in we saw how it is relevant to each customer. Then we saw this concept of how networking happens, the various services that allow networking to happen. We then saw we then saw the what a region and availability zone is, as in how they are like linked together. And then we saw a very basic formulation of how like these various services, how these various concepts are linked. Like these are services, and then these are and like how they are present in various regions, and how and what IAM users are. And then we saw like the various services in uh, we then saw the various services in AWS. Then after that, all these services were explained. We saw what EC2 was capable of doing. We saw what auto scaling is. We then saw we discussed elastic load balancing. We saw the storage services that's available, database services that are available, application services that are available, and then yes, the various services that are available. And finally, uh, just a second. And we saw the various services that are available, and then we saw an existing system architecture of a website, and how AWS could be used to convert it. Well, not exactly convert it, but how AWS could exactly be used to build that same architecture, right? So if you have a basic understanding of the services in AWS, you can you will be able to develop these kind of uh, system architectures. Okay, so let's begin. Let's begin with the question answers. Mm, okay. So, firstly, in edge computing, how is resource allocation typically managed? Is it is
Answer C, sir.
wait just a second. So, in edge computing, how is resource allocation typically managed? Is it A, centralized allocation from a single server, B, random allocation based on user demand, distributed allocation across edge devices, or manual allocation by administrators? I will go through these sections quickly. See, I have to discuss this because uh, I have to discuss these kind of questions because some kind of similar ideas were discussed in the original lectures as well. So, okay. So, ma'am has said C. Selvi ma'am has said answer C. Anybody has any other responses? Okay, fine. I'll go through this quickly. The answer is definitely C. Distributed allocation across edge services. So, of course, these ideas have been discussed in previous lectures too. So I'll just say it very briefly. So edge devices allow the cloud to be distributed in nature. So as a consequence of that, you can say that the answer is C. Others are not very relevant. The second question is, what is the primary? 1 minute. So okay, so before I continue, I just want to give credit to Ranish and Shweta Verma for uh, for producing these questions over here, and some AI tools were used such as ChatGPT, and yes. So what is
Answer B, sir.
uh, just a second. So what is the primary advantage of distributed resource allocation in edge computing? Is it A, increased latency, B, reduced bandwidth consumption, C, higher dependency on centralized servers, or D, limited scalability? Any other responses? So yes, so the answer is B. It helps in reducing the bandwidth consumption. Um, so of course, now that's mostly because if you have data that is processed at the edge, what will happen is if data has been processed at the edge, you will have no need to send that data to the cloud. So the edge device can immediately respond to the user, and the edge device will most likely be close to the user as well. So that is why B is the right answer. And increased latency is not necessarily the case with edge devices, because edge devices will be close to the user, so the round trip time will be reduced, and or in other words, the distance for the data to travel from the end device to the cloud will not be that much. C is also wrong because the edge is not centralized. Limited scalability is not necessarily always the case. It does not follow from this. So in the context of edge cloud systems, what does optimization typically refer to? Is it A, maximizing energy consumption, B, minimizing latency and improving performance, C, increasing server downtime, or D, expanding data storage capacity? Are there any responses?
Minimizing latency and improving performance.
Yes. Yes, so that is the correct answer. So I think the answer to this question is self-explanatory. So maximizing energy consumption is actually not an appropriate goal. We ordinarily want to minimize it, and in the context of edge cloud systems also, like the energy consumption has not clearly been discussed in the course. But even if it had not been discussed, like maximization of energy is not a good optimization strategy. And increasing server downtime, so that's a negative thing. We don't want that to happen. We want the server to be up as often as possible, so that it can serve the user. Expanding data storage capacity. Now this can be like somewhat confusing. Even though it is a positive goal, we don't always the edge does not necessarily achieve that, because see, one thing is the cloud already has sufficient data storage, and the cloud only the limitation of the cloud, which is which is the high latency. That is the only thing that keeping devices close to the user um, can actually help. Okay, but it is not exactly D. Even though to some extent edge devices can actually help improve data storage capacity. But if we want to like expand data storage capacity, we have enough avenues to do it at the cloud itself. So I'll skip this question. So since we are in this collaborative cloud edge thing, so what does a collaborative cloud edge environment primarily aim to achieve? Is it A, isolation of resources between cloud and edge devices, B, centralized control over edge devices, C, cooperation and resource sharing between cloud and edge components, a strict hierarchical organization of computing resources? Does anyone have any responses? See now, the title of this lecture is the title of the first lecture had something to do with collaborative cloud edge, right? Collaborative cloud edge approaches. So we're just covering this part properly. So what does a collaborative cloud edge environment primarily aim to achieve? Is it A, isolation of resources, B, centralized control over edge devices, is it C, cooperation and resource sharing between cloud and edge components, or D, strict hierarchical organization? Please think about this. Okay, fine. So the answer to this question is C. Right? So cooperation and resource sharing between cloud and edge components. So so why is this? So why is that? So what does collaborative mean, right? So collaborate in a way means one is helping the other and the other is helping the other, right? And so fundamentally, now what that will allow is now another way of expressing that is cooperation and resource sharing, right? So one is cooperating with the other in the form of resources, like one is giving other, one is allowing, one is giving, uh, when a demand has been placed on the system, one is giving its virtual machines to, one is serving virtual machines for processing the demand, and if that is insufficient, then the other is giving some virtual machines to process its demand. So yes, so quite a lot of that is happening. So that is a consequence of the word collaborative. Right? So B is obviously wrong because edge devices have a lot more to do with distribution, with enabling distribution, and we don't want resources to be completely isolated between cloud and edge devices because uh, because that would actually make the system inefficient, and that would also go against the word collaborative. Now we don't want everything to be strictly hierarchical also, right? So the edge should be able to give the cloud some commands, the cloud should be able to give the edge some commands, right? We don't want everything perfectly master slave. So I hope that is clear. So which of the following characteristics is typically associated with a collaborative edge cloud environment? Is it A, increased latency for edge devices? Is it A, increased latency for edge devices? B, reduced flexibility in resource allocation? C, enhanced scalability and responsiveness? Or D, limited connectivity between cloud and edge devices? Does anyone have any responses? Yeah, I guess I'll just wait 15 to 20 seconds, then I'll explain the answer. Which of the following characteristics is typically associated with a collaborative cloud edge environment? Is it A, increased latency for edge devices? B, reduced flexibility in resource allocation? C, enhanced scalability and responsiveness? Or D, limited connectivity between cloud and edge devices? C, okay, fine. So C is the correct answer. Now why is that? Of course, the collaborativeness is going to allow, uh, is going to firstly allow the responsiveness. So because if these two were not collaborating, maybe if the cloud and the edge were not collaborating, maybe when the resources were overloaded on the edge, and the cloud may not be able to respond with virtual machines, but since they are capable of collaborating, the cloud will respond with virtual machines. And as far as enhanced scalability is concerned, uh, definitely, since you can provide a lot more VMs than normal, you can say in a way that more you are able to provide more VMs in response to demand. So that is a, in a way you can call it scalability. So limited connectivity is not necessary, is not always true. So it's not necessarily true. The more edge devices you have, you will also have to allocate some amount of connectivity related resources for that. You have to allocate some sort of network related resources, and then reduce flexibility. That's once again not true, because if the edge and cloud are collaborating, they can always create VMs for each other. Increase latency for edge devices, once again that's also not necessarily true. Like uh, collaboration will not necessarily do that. It will only it will only require you, it will only give you the latency that like already exists. It's, so either the application is unresponsive or it has a certain latency. So what defines an industry 4.0 environment? So is it integration of physical and digital technologies in manufacturing and production processes? Is it B, strict adherence to traditional manufacturing methods? Is it C, reliance solely on manual labor for production tasks? Or D, minimal use of automation and data analytics? A. Okay. Any other responses? Okay, fine. So yes, so A is the correct answer. So how is this enabled, right? Oh, just a second. So how is Industry 4.0 enabled? So Industry 4.0 is enabled uh, by because of IoT, right? So what happens in IoT? You have a lot of devices that are connected to each other via some sort of through sensors and everything, via some sort of network connection. So fundamentally, it is the IoT that enables Industry 4.0. So what happens in IoT is the physical and digital technologies in manufacturing and production processes are integrated, right? So the rest are wrong by self-explanatory. Okay, I'll just skip this question. So which of the following is okay? I'll skip this question too. So which component of cloud services is responsible for distributing incoming network traffic across multiple servers? Is it A, database, B, the load balancer, C, virtual machine, or D, API gateway? Any responses?
Load balancer.
Yeah, it is the load balancer. You're right. Okay, fine. So now let's go to this one. So, what distinguishes a private cloud from a public cloud? Is it A, private cloud offers services to the general public, while public cloud is exclusive to organizations? B, public cloud is hosted on premise, while private cloud is hosted off premise. Private cloud is managed and used exclusively by a single organization, while public cloud is shared amongst multiple organizations. Or D, public cloud provides dedicated resources, while private cloud shares resources with other organizations. What's the answer to this? Any responses? So what is the, does anyone have any responses to this question? Yeah, okay. So yes, so the private cloud is managed and used exclusively by a single organization, while public cloud is shared amongst multiple organizations. So let's take a look at your notes. So I mean, you can kind of sorry. That is directly in the definition of the private and the public cloud. So it's not exactly discussed in this lecture, but in the previous lectures as well, there has been some content related to this. Um, Now in this lecture, the definition was actually extended to mean some other idea, to include some other ideas as well. For example, in a public cloud environment, the cloud provider offers different pricing modes for cloud services based on the demand characteristics. And in a private cloud, the edge node has its own virtual machines to process user demands. So you can see that the cost model actually differs significantly across the public and the private cloud because of this. Which of the following statements best describes the accessibility of a public cloud versus a private cloud? So, a public cloud is accessible via the internet to anyone, while private cloud is accessible only through a dedicated network. A private cloud is accessible via the internet to anyone, while public cloud is only accessible through a dedicated network. Both are accessible only through dedicated network. Both public and private clouds are accessible via the internet to anyone. Which of these best describes?
D.
Sorry?
It's D.
D? Yeah. D? When did he say it's D? Okay, Preeti R says C.
Yes.
So both public and private clouds are accessible via the internet to anyone. So can I access Oracle's private cloud from here? Do you think so? Okay, Ruchita Sharma says A. Okay, so there is some confusion between between A and D and C and A maybe. So the public cloud is accessible to anyone by definition. Well, not necessarily anyone, but there are some conditions for you to access it. But on average, you can say, right? But the private cloud it's accessible definitely only to like some very few like dedicated people. Okay, and so it might be through a VPN, through a virtual private network. That is the dedicated network that is being spoken about. But it is not always the case that the private cloud is accessible to the internet via to anyone. Let's give this. Okay, fine. Fine. Okay. Let's should we skip this? Okay, fine. Okay, let's take a look at this. Okay, you've already seen the answer, but anyway, in the context of edge computing, what does multi-edge refer to? Okay, so is it having multiple layers of security for edge devices? Just a second. So in the context of edge computing, what does multi-edge refer to? Is it A, having multiple layers of security for edge devices? Is it B, utilizing multiple edge computing platforms simultaneously? Is it C, implementing edge computing in multiple geographical locations? Or is it D, providing redundancy in edge node deployments? So that's not necessarily true. Savi ma'am has said B. So okay, I'll tell you the answer to this question. So by definition, it means implementing edge computing in multiple geographical locations. So what does multi-edge node conditions typically involve? Is it A, deploying a single edge node across multiple edge locations? Is it B, utilizing multiple edge nodes to process data in a distributed manner? C, having redundant edge nodes in a single location for failover purposes? Or D, implementing edge computing with different operating systems on each node?
D. It's D.
Uh, Not true. So multi-edge kind of implies that there are multiple edge devices, right? So okay, fine. So the answer is so when you have multiple edge. Okay, I said A. So yes, so A is also a correct answer. Definitely.
So the answer is B or A, sir?
I would say it's A and B. Okay. Oh no, sorry. It's not A. Here it says single edge node. No, A is not the correct answer. I'm sorry. So over here it says deploying a single edge node across multiple geographical locations. So it's not A. Okay. The answer is B. Okay. So multiple edge nodes to process data in a distributed manner.
Oops.
Fine. So, uh, so these edge nodes can be in various regions as well. It's not necessarily that these edge nodes will be in like one geographical regions. Okay. So redundant edge nodes that can be there, but they're not like primarily contributing to the definition of multi-edge. Okay. So which pricing mode for resource allocation in cloud services charges users based on their actual usage? Is A, fixed pricing, B, subscription pricing, C, pay as you go pricing, or D, tiered pricing?
B, sir.
Um, so that once again, that's not necessarily always true, right? So let's say I've subscribed. Let's say I pay monthly subscription for some sort of virtual machine, right? And if I pay for that monthly subscription and I don't use it for a certain month, my money will still be gone, right? Okay, so the answer is B. The answer is C. Okay, it's pay as you go pricing. Oh, I'm sorry. So, what pricing mode for resource allocation in cloud services involves paying a set amount for a predetermined level of resources over a specific time period, right? So, over a specific time period. In fact, I had just discussed this. So, is it A, variable pricing, B, spot pricing, C, subscription pricing, or D, pay per use pricing? So yeah, so Ruchita Sharma has said C, subscription pricing. Yes, so that is the correct answer. Does, but does anyone have any other? Okay, I'll just go to the next one. It's not very challenging. So which pricing model is prevalent across? Uh, yeah, oh, one second. So which pricing model is prevalent across most cloud vendors, offering three different price modes? Is it A, on-demand instances, B, reserved instances, or C, spot instances, or D, all of the above?
Answer A, sir.
So I don't know if you remember, like the public cloud, right? The public cloud equation. So we had a parameter for various different kinds of pricing models, right? So just think about that equation once. So is it on-demand, reserved instances, spot instances, or D, all of the above?
Okay, all of the above, sir.
Okay, let's see the answer. Yes, so the answer is D, all of the above. Okay. Basically, all three are provided. So, which pricing mode in cloud services allows users to rent computing resources with no long-term commitment and pay only for what they use? Is it A, on-demand instances, B, reserved instances, or C, spot instances, or D, none of the above?
Answer C.
Spot instances? Are you sure?
C, sir.
Okay, so the answer is A, okay? Fine. So the answer is A, it's on-demand instances.
Okay.
Okay, fine. I mean, you can look up the definition of these other. Just one second, I'll just set up one thing.
So when the spot instances will be used?
Just give me a second. So it's like so basically spot instances is like a kind of you can say like it's at a discounted price, right? So if there are some like if there are some resources that are like not like fully used, right? Let's say AWS has some resources that are like completely unused. Like it can if you request a spot instance, it can give it to you. But the only problem is it can like terminate it randomly. So that is the only problem. Okay, this problem is not there for like a reserved instance or on-demand instance. Just one. I'm really sorry for this interruption. I just need to. Okay, fine. Why is coming up? Oh, I'm sorry. Okay, okay. So let's start with this one. Okay. So how is time typically managed in the cloud edge environment described? So I think we'll just go into the formulation directly. So is time continuous and unsegmented? Is time discretized into time slots, or is C, time synchronized with external clocks, or D, time is managed by edge nodes exclusively? So Ruchita Sharma says A. Oh no, I'm sorry. I think for the previous question. So does anybody have responses? Time is continuous and unsegmented. Time is discretized into time slots. Time is synchronized with external clocks. Or D, time is managed by the edge node exclusively.
Answer B, sir.
B? Okay. You mean B, like the second one?
Yes, sir, yes.
Okay. Yeah, so time is discretized into time slots. That is true. So you must have, I don't know if you remember the equation that we had created an allocation record, and inside those allocation records we had put some records of demand and how long we want to use that virtual machine for. So at the end of every time slot something happens, right? So from that you can kind of infer that time was discretized into time slots. So in the context of computing tasks, what is the significance of discretizing time into slots? Is it A, it ensures continuous processing without interruption? It allows for better synchronization between edge and cloud nodes. It facilitates calculation of computing costs and task scheduling. Or D, it simplifies user settings management. So in the context of computing tasks, what is the significance?
Answer C, sir.
Answer C. Yeah, that is true. Does anyone have any other responses? So yeah, so definitely the answer is C. It facilitates the calculation of computing costs and task scheduling. So so basically, I don't know if you remember, we had some cost, right? Standby cost that was calculated based on some other equations. So all those, a lot of those equations were based on us discretizing the time into various time slots. How is user demand defined in the described cloud edge environment? So A, it is defined as the total number of virtual machines requested over all time slots. B, it is defined as the average duration for which virtual machines are requested. Defined as a pair consisting of the number of virtual machines requested and their duration. Or is defined as the maximum duration for which virtual machines are requested in a single time slot.
Answer C.
So, okay, does anyone else have any other responses? Is there any confusion between C and D or something?
Answer C, sir. Because user demand is always specified as a pair.
Yeah. Okay, fine. So yes, so it is definitely a pair. So it defined as a pair consisting of the number of virtual machines requested and their duration. So if we look at let's look at your notes. So it is this pair that I'm talking about. The demand submitted by the user can be defined as the following: dt equals dt comma lt. So this is a tuple over here. So or you can call it a pair. So dt is the number of VMs requested. LT is the computing time duration of dt. Right? So if you look at this, this is the answer. So of course now, of course intuitively, right, you will kind of infer that this LT is actually the maximum time duration. However, what I it has not really been made clear in the slide whether this is the maximum possible time duration or not, right? So so this most likely is some sort of guess that is submitted by the user. Okay. So, so what does the term IT represent in the user demand equation? Oh no, wait. Let's ignore this. Uh, Sorry, there was a mistake here. Actually, this was LT. Anyway, so how is the user demand defined in the described cloud edge environment? It is defined as the total number of virtual machines requested. Oh no, wait, this is already done. I'm sorry. There is some amount of. So I'm sorry. This week I actually was really busy, so I had a very hard time actually getting these MCQs done. I had some field work for my PhD, so which is why the session was also postponed. Anyway, I will. If you want, I can create some more better questions and send it to you later. Okay, so how is the number of virtual machines provided by the edge node calculated in the described scenario? It is calculated as the total demand minus the resources met by the cloud. It is calculated as the total demand multiplied by the number of available virtual machines. It is calculated as the difference between the total demand and the available virtual machines, calculated as the total demand divided by the number of available virtual machines. So can we, so what is the answer to this question?
Answer C, sir.
Total demand and the available virtual machines. Are you sure? Any other responses? Total demand.
Oh, sir.
Hmm?
Or answer A, sir.
Okay. I don't want to reveal the right answer now. Let's just look at some more responses and I will. Anyone have any responses? Okay, so the answer is A, right? It is calculated as the total demand minus the resources met by the cloud. So if some resources are met by the cloud, you can so, you can subtract them and you get whatever the relevant edge nodes are. Okay, fine. So if I make any mistakes or anything, you can just email me. So under what condition does the equation for calculating the number of virtual machines um, sorry okay, let's go to the next one. So how is the number of remaining virtual machines at the edge node calculated for the next time slot t plus 1 in the described scenario? It is calculated by subtracting the demand met by the edge node at time t from the number of virtual machines at the beginning of time slot t. It is calculated by adding the demand met by the edge node at time t to the number of virtual machines at the beginning of time slot t. It is calculated by subtracting the demand met by the cloud from the number of virtual machines at the edge node at time t. It is calculated by adding the demand met by the cloud to the number of virtual machines at the edge node at time t.
Answer C.
Okay. Let's see. Any other responses? It is calculated by subtracting the demand met by the cloud from the number of virtual machines at the edge node at time t. Is one response. Any other? Okay, fine. So let's take a look at the nodes. Okay, at the nodes. So the question was at time t plus 1, how is the number of remaining virtual machines at the edge node calculated? Right. So the number of remaining VMs at the next time slot t plus 1 is calculated based on the number of remaining VMs at the beginning of time slot t. Okay, the quantity allocated at the end of time slot t, and the quantity released due to completion of the edge computing nodes at the end of and the quantity released due to the completion of the computing task in time slot t. Okay, so that will now let's look at the option A. It is calculated by subtracting the demand met by the edge node at time t, right? So this minus det is the demand that has already been met by the edge node. Okay, from the number of virtual machines at the beginning of time slot t. So et minus det is also, and after that we have this eta t term. This eta t term is the number of VMs waiting to be released at the end of time slot t. Okay, so if you keep this equation in mind, right, you will get this. You will see that the answer is it.
So A is the answer, sir.
Yes. So how is the cost of the edge node at a given time t typically calculated in the described scenario? Oh, and if you think I've made any mistakes, please feel free to send me an email. Okay. So it is calculated as the sum of the standby cost and the computing cost. It is calculated as the difference between the standby cost and the computing cost. It is calculated as the product of the standby cost and the computing cost. It is calculated as the quotient of the standby cost divided by the computing cost. Any responses? What is the cost of the edge node at a given time t typically
Answer A, sir.
as the sum of the standby cost and the computing? Let's wait for some more responses. So just keep the notes also open parallelly, then it will all be clear. Right, so what are we doing when we want to calculate the cost of the edge node, right? So how are the standby costs and the computing costs related? Okay, fine. Let's see the nodes. The sum. So there's a standby cost, which is ETPE, and there's a computing cost, E minus ET times PF. Now both of these are being added, right? That is how we get, it is calculated as the sum of the standby cost and the computing cost. Okay, so that is the correct answer. It is calculated as the sum of the standby cost and the computing cost.
So in this equation, what is P and the PF, sir?
So P and PF, right? So let's look at so there was a problem that was actually given to you, right? uh, let me see if I can find it. E1PE over here, right? I think in the problem, I just want to explain with an example. I think that would be a good idea. Yeah, okay, got it, got it. See over here, do you see this? Is it visible? So PE is
Yes,
the
it's
standby cost of a VM at the edge node, PE, and PF is the computing cost of a VM at the edge node, PF. Okay, fine. I hope it's clear. Okay, so should I keep this? Do you want to do this question? Okay, fine, fine. So for now, you can actually see, just refer to your notes. So this is not a universal kind of thing. Okay, so even I wouldn't be able to answer this question without looking at the notes. But in the notes, right, what does X1 stand for? Is it the cost of you should have some understanding of what this X1 is. So in the cost function of the public cloud services, what does X1 represent? Is it the cost of on-demand instances, cost of reserved instances, cost of spot instances, or cost of standby instances?
oh, it's the cost of on-demand instance. And so
Hmm. So yes, so that is true. X1 is the cost of on-demand instances. Let's see if we can find it. Yeah, okay. So if you look at the notes over here, X1 over here is the cost of on-demand instances. So what does X2 represent in the cost function for public cloud services? Let's do this quickly.
answer B, sir.
B. Anyone have any other responses?
Is this the cost or is just a binary 1-0 variable? If you see the equation, it's not cost, it's actually 1-0.
Yes. Yes, yes. So x1 being 1 means that this entire equation, like POD times DTC will be used, right? So it means when we are using this service, we want this cost part, we want this to be applicable. So it's like a parameter, you can say. So this entire thing is a cost. Oh, okay, you're talking about this. Okay, okay, fine, fine. Uh, see,
So
see. So this
X1
entire,
is just a binary variable. The
yes, yes.
cost is actually the POD into
Yeah,
DCP.
yeah. You're right. You're right. But X2 is not exactly the cost. So I just want. I apologize for this. Okay. Um, so it is simply a parameter. So I will see if I can make this change. I'll just make a note of this. Right. Okay. Fine. So thanks for pointing that out to me. Um, yeah. So the entire expression over here, this entire expression represents the cost. Okay. So it's not the x1 alone and x2 alone. These two don't exactly represent the cost. These two are just parameters. Okay. So these two are just parameters which determine whether these cost expressions will be contained in the final cost expression. Okay.
Okay, sir.
Okay. Anyway, just ignore. Fine. So So in the Markov decision process, what does S represent? In on the Markov decision process formulation for resource allocation, what does S represent?
Finite set of states. A.
Okay. Anyone has any other responses? Okay, fine. So let's look at your notes. Okay, so over here, some Markov decision process is a tuple where S is a finite set of states. Okay, fine. So it's not very challenging. So how are states defined in the Markov decision process formulation for resource allocation? Is it A? States represent the number of actions taken in each time slot. B. States represent the probability of transitioning between different actions. C. States represent the state of the edge node at the beginning of each time slot, including the number including the number of remaining virtual machines, leased virtual machines, returned virtual machines, user demand, the unit cost of virtual machine. Or D. States represent the immediate rewards gained from each action taken. So anyway, this is also pretty easy, but yeah, just answer this question. Are there any responses?
Answer C, sir.
Okay, any other? Okay, so yes, so the answer is C. Let's take a look at your notes. So what is the state, right? In the Markov decision process. So the state of the edge node contains one, the number of remaining virtual machines at the edge node, the number of virtual machines returned in the previous time slot, users demand information in T, unit cost of VMs in private cloud. So number of remaining virtual machines, leased virtual machines. You can say number of remaining virtual machines, a number of, so this you could say this is kind of equivalent to the leased virtual machines. This is the returned virtual machines. User demand and unit cost of virtual machines. User demand information is here, and then unit cost is also here. Okay. So, so in the Markov decision process, what does XC represent? Is it A, the total number of virtual machines provided by the edge node, the ratio of virtual machines provided by the edge node to the total number of virtual machines, the ratio of virtual machines provided by the cloud node to the total number of virtual machines, D, the unit cost of virtual machines provided by the edge node. Anyone has any responses? So Savi ma'am has said B. So the ratio of virtual machines provided by the edge node to the total number of virtual machines, right? And another one is the ratio of virtual machines provided by the cloud node to the total number of virtual machines. Oh, I'm sorry, I meant XE, right? So there's no such thing as XC. Yeah, I think now it will be more clear. Okay, now can you all answer? Okay, fine. So if you look at XE, right? XE is the ratio of the virtual machines provided by the edge node to the total number of virtual machines, right? So yes, so the answer is B. Okay, you can just take a look at the definition of the variable. It's also very simple. So what does xk represent in the Markov decision process? So is it A, the total number of virtual machines provided by the edge node to the total number of virtual machines? B, the ratio of virtual machines provided by the edge node to the total number of virtual machines? The ratio of virtual machines provided by the cloud node to the total number of virtual machines? Or D, the unit cost of virtual machines provided by the cloud node? Does anyone have any responses?
Answer C, sir.
Yeah, okay, fine. So you're right. The answer is C. The ratio of virtual machines provided by the cloud node to the total number of virtual machines. The answer is definitely C. Okay, and let's take a look at your notes. The ratio of number of virtual machines provided by the cloud node to the total number of virtual machines. Okay. So how is the reward function represented in the Markov decision process formulation? Is it A, the reward function is represented as the total cost incurred by the private cloud? B, the reward function is represented as the difference between the private cloud cost and the edge node cost. The reward function is represented as the negative of the private cloud cost. A reward function is represented as the total number of virtual machines provided by the private cloud.
Answer C, sir.
Answer C. Does anyone have any other responses? So why private cloud, right now? That may also be a question. Does anyone have any other responses? How is the reward function represented in the Markov decision process formulation? The reward function is represented as the total cost incurred by the private cloud. The reward function is represented as the difference between the private cloud cost and the edge node cost. The reward function is represented as the negative of the private cloud cost. Or the reward function is represented as the total number of virtual machines provided by the virtual cloud. Okay, fine. So I won't take too much time on this question. So CT pri, right? So cost, the private cloud cost. So it is the reward in each time slot. So we take the negative because see, because when we want to, because it naturally maximizes. So if we do the negative of the maximization, we'll come to minimization. Okay. So CT private reward as the as the total cost incurred by the private cloud. Fine. So yeah, so that is the correct answer. Oh, I'm sorry. Yeah. What represented as a negative of the private cloud cost. What does the reward function signify in the context of resource allocation in the in the context of resource allocation in the Markov decision process? Is it A, the efficiency of the edge node in meeting the user demand? B, the cost incurred by the private cloud for providing additional resources? C, the total number of actions taken by the edge node? Or D, the number of virtual machines provided by the edge node? This is also restating the previous question, but just think about it. What does the reward function signify in the context of resource allocation in the Markov decision process? Efficiency of the edge node, cost incurred by the private cloud, total number of actions taken by the edge node, or D, the number of virtual machines provided by the edge node.
Yes, sir. Answer you.
Efficiency of the edge node, right? So, and if when you want to discuss efficiency, you need some kind of comparison. So let's think about this carefully.
Here the answer will be B, but one thing, reward function, why are we putting only the cost? Yeah, like we are not taking the other things like if if we use edge VMs over uh, cloud VMs, the latency will be less. So I am seeing here the reward function to the optimization algorithm. We are giving only the cost. Shouldn't it be also a function of the uh, latency effect that
Okay.
if we are able to give through edge node VMs, then
Hmm.
we have some advantage of latency. The professor said it is also a function of latency, the optimization algorithm, but in the equation I'm seeing only the dollar amount is stated.
Okay. Which equation are you referring to?
The reward function, why is it only cost dollar amount? It should be also a function of uh, latency,
Of
means
latency. So.
as in if we give resources from VM edge node instead of cloud, then the latency will be less. So
Yeah, that is true. So I think so I think when you kind of see, of course, I also don't know the answer to this question directly. See, one thing is this is a very general formulation. Okay, so like it's not like every time. See, every time let's say you're a provider, right, and you want to work on the work on creating some sort of optimization algorithm for your specific use case, right? So you don't have to like always use this kind of formulation always.
hmm,
So like you can, or you also don't have to always use like something like reinforcement learning, right? But one thing is, I think this might be somewhat dependent on the scenario that you are working on as well. Okay, so let's say, uh, see, one thing is it might be if it's, let's say, not, if latency is not really an issue to you, let's say, then you may not want to include it in your reward function. But if it, let's say, a lot of or 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 let's say if it is a bigger issue for you to provide, like spin up virtual machines, right? let's say if it is a bigger deal for you to spin up virtual machines, then in that case uh, you might want to, let's say, include that in your cost. But I'll tell you one more formulation. Okay, so uh, what what people generally do is, so in the reward function, right, they will multiply. Let's say there are two things.
Weighted function.
Yeah, yeah, yeah. They will give some weights to each term that they want to optimize. So if they, let's say, want to optimize one term more, they will give it a bigger weight, right? But
Weighted function.
yeah, and so, and let's say for example you can consider this minus ct pi plus 0 into latency. Of course, but once again, this is not really. I don't think every cloud provider that is doing optimization is using this exact reward formulation. So yeah, I mean, uh, but yeah, like why the professor did decided not to include not to include latency, that I don't know as well. Okay, so
I think so. He said by mouth, but
hmm?
during the means he said latency is a factor
Okay,
while optimization, but didn't include in the equation. Yeah.
okay, okay. So maybe he also wanted to say that I don't remember the professor's exact words, but did he say that this cost included some had was a function of latency in any way or something?
No, no, no.
He didn't say.
He meant reward means he meant the
Hmm.
resource allocation strategy should be catering to uh, all the all kinds of functions like cost, a latency, etc., RTT, these all. But ultimately, while when he came to the equation in the reward, he didn't include that.
Okay, fine, fine.
Okay, it depends upon the use case actually.
Yeah, yeah, yeah. Ideally, it will depend on whatever is more challenging for you to optimize, right? So that is how you generally decide the reward function. So
By the
actually,
way,
hmm?
this reward function is uh, like the user specific, right? Like use case specific.
Yeah, yeah, use case specific.
So,
Generally, like,
so this algorithm's reward function, basically the optimize, say max of this,
hmm,
is provided not only by the CSP but also by the user, right? Customer user end, right? They should also help define the resource allocation strategy, right? Because if I am a
hmm,
manufacturing plant, say,
hmm,
who needs this edge application,
hmm, hmm.
so I should also, to me, along with cost, latency is also a factor. So in that case, I should also tell the CSP in your resource allocation strategy, please give a weighted function of latency, right?
Okay, so
Uh, it
uh,
comes to the user end as well, right?
so I don't. So the user generally does not have that kind of control. But I don't know if you have heard of this thing called a service level agreement, right?
Yeah, yeah, that happens before any.
Yeah. So well, let me just like Google that in front of you, so that I just don't make a mistake in that. So like we generally don't want to give the user that level of uh, we don't want the user to give like that level of control, right? Because I'm just guessing there might be the possibility of like hacking, or some malicious user may do something, right? So, or they may find some way to hog resources if you allow a user to define their own optimization their own reward function, right?
So
You shouldn't.
this optimization algorithm is completely controlled by the CSP. Then
When you say CSP, you mean cloud service provider, right?
yes, yes, yes.
Okay, fine. Yeah, ideally. I mean, the user can. I mean, the user can only put like requests and demands and all that.
Okay.
And but all that happens while you consider this thing. But all those demands and stuff, right? We do all that while considering the service level agreement. Okay.
So basically, during the SLA, the user will tell that I need latency also as a factor, while
Yeah, yeah, yeah. All these things are included in that. That
and
downtime.
accordingly the RA function, reward function will change. Basically.
Yeah, I mean that internal what happens. See, I am not an employee of AWS, so I cannot say how the reward function is changing. But I even intuitively it makes sense for their for them to maybe switch the reward function a little bit if let's say the user puts some kind of demand. So I don't know what actually happens inside AWS, right?
Mm-hmm.
But what I know for sure is that they have to comply with this SLA. Whatever is their service level agreement, they have to
Mm-hmm.
comply by it. Like, okay, fine. So should we? Okay, oh man, I keep showing you all the answer, unfortunately. And anyway, in a cloud environment, what decision problem arises when considering different types of offerings from a public cloud? Is it A, continuous decision problem, B, a parameterized decision problem, C, a reinforcement learning problem, or D, a supervised learning problem? Anyone have any response to this? So this, I don't know if you remember the equations.
DB.
Hmm. Okay. Any other? Okay. So why? So yes. So the answer is B. Okay. So in a cloud environment, okay, it's 6 o'clock. I have half an hour left. Anyway, so in a cloud environment, what because of the different types of offerings from a public cloud, it leads to a parameterized decision problem. Okay, let's take a look at the equation from for the public cloud. So these are all parameters, right? X1, x2, x3, x4. So because of the way these parameters vary, you kind of uh, come to some kind of public. You kind of come to some kind of decision problem. So of course, it's not reinforcement learning problem because see now even though in this lecture we have discussed reinforcement learning to be able to solve this problem. So reinforcement learning is not the only way to solve this kind of optimization problems. So these kind of problems they fall under something called meta heuristic. These kind of problems, right? You can solve them with something called meta heuristic algorithms as well. So um, any kind of optimization problem can at least be addressed using these kind of problems. So reinforcement learning is not the only solution, but you can use reinforcement learning to solve these kind of problems. Supervised, of course, is not true because we don't have any labels. We have an environment that we want to minimize the reward or maximize the reward for. So, what role does the parameterized action space uh, play in the context of resource allocation in a cloud environment? Is it A, it allows for continuous actions to be taken in the environment? B, it facilitates decision making based on different types of public cloud offerings? C, it restricts actions to discrete choices in the environment? Or D, it determines the number of users for accessing cloud services? Okay, so the answer is B. Okay, so it facilitates decision making based on different types of public cloud offerings. Okay, so let's see if we can. I'll just do some reinforcement learning questions. Then I'll move to like the next chapter. Okay. Uh, there's let me do some. Okay, I'll just send these questions to you. Okay. Um, I don't know if we'll have time to do this. Okay. So which anyway, you've seen the answer. Anyway, which reinforcement learning algorithm is often used for parameterized decision making in cloud environments? Is it A, deep deterministic policy gradients, B, Q learning, C, random forest, or D, k-means clustering? Okay, fine. So the answer to this one is A. Deep Q is DDPG or deep deterministic policy gradient. So we don't use Q learning directly because one thing is it's not really sophisticated enough, and the other two are not even reinforcement learning agents.
Answer yes, sir.
Yeah, answer A, correct. What is the main objective of the deep deterministic policy gradient algorithm in resource allocation? Is it A, to minimize the total cost incurred by the private cloud? Is it B, to maximize the utilization of computing resources? C, to learn an optimal policy for action selection? D, to allocate resources based on user demand?
Answer A.
Well, you could say A is not wrong exactly, but the most appropriate answer, right?
D, DB.
Uh, yeah, you could say this is multi correct. So I would say, for me personally, I think C is the correct answer, right? So DDPG, it kind of uh, it wants to learn an optimal policy for to select an action. So D is also right, of course, because based on the demand only it will select. A is also right because it wants that reward function, it wants to minimize. That reward function is a private cloud function, right? So and then after that, yeah, and B is obviously wrong, right? Because if you want to maximize the you don't want to maximize your utilization, you want to minimize it, right? So that's why we have the negative in the reward function. Okay, fine. Let's go to the next chapter.
So answer is
Okay, one second. So the answer is A, C, and D.
okay. Okay.
Right? And if I make any mistakes, you can let me know. Let's open your. Fine. So let's start here. So what is described as the first layer in the AWS services model? Is it A, the infrastructure layer, B, the application layer, C, the networking layer, or D, the storage layer? the AWS services model? Is it A, the infrastructure layer, B, the application layer, C, the networking layer, or D, the storage layer?
Yes, sir.
Yeah, so A is the correct answer. So even if you look at your slides, so the AWS. So I don't know if you remember, like Sir had started from the bottom, right? When he was discussing the nodes. So AWS global infrastructure, then the next one, then here, then in the end it came to deployment and administration. Okay, so the infrastructure layer is the answer. How are AWS's services categorized according to the provided text? Is it into 3 layers, 4 layers, 5 layers, or 6 layers? Categorized according to the provided text. Is it into 3 layers, into 4 layers, into 5 layers, or 6 layers?
Answer B, sir.
B, 4 layers? So
And
sorry?
right,
Yeah, so yes, so there are 5 layers, right?
5 layers. Yeah, 5 layers.
1, 2, 3, 4, 5. So which layer in the AWS services model is responsible for providing public cloud services? So is it layer 1, layer 2, layer 3, or layer 5?
Layer 2.
Hmm?
three. Mm.
Providing
Layer two, sorry. Two.
layer 2. So what I'm fundamentally asking is, what is the most fundamental uh,
Layer two, three, both.
huh? Like,
Three is main.
okay, you can, in a way you can say all the layers, but but you can say okay, fine. Actually, let's skip this question. There can some amount of confusion can happen. Okay, I'm not in a position to justify it right now. But for now, let's just skip this. Okay. So what is described as mimicking cloud services in the cloud edge architecture? Is it A, cloud-based applications, B, edge computing, C, collaborative models, or D, public cloud services?
Collaborative model, sir.
No.
Edge computing.
Yeah, it's B, edge computing. So what is, we see that edge computing mimics cloud services, right? So, the answer is edge computing. So what does the cloud edge system mimic? Okay, is it on-premises computing? Is it cloud-based services? B, C, collaborative models, or D, virtual private networks? So what is it mimicking? Like this entire this cloud edge system, right? So what is it looking like in a way?
Cloud-based services.
Yeah, you can say definitely. So just the cloud edge system, it is going to be mimicking like just pure cloud-based services. If you if you if you if you have edge computing. Yeah. So which of the following statements is true about the relationship between edge computing and cloud computing. Okay, so they have no functional similarities. Edge computing provides completely different services from the public cloud. Edge computing offers some form of all the services available in the public cloud. Public cloud services cannot be replicated in edge computing.
Answer C.
Yeah, definitely. Edge computing offers some form of all the services available in the public cloud. Okay, so edge computing. Uh, yes, that is definitely the right answer. Let's see. Let's move to some. Okay, okay. So, what is emphasized as a benefit of utilizing AWS regions for location dependent services? Is it A, reduced latency, B, lower costs, C, uh, enhanced scalability, or D, improved security?
Reduce latency.
Okay, any other responses? Okay, fine. So, let's take a look at your notes as well. Right, so where is this being discussed? You know, if you remember. So, yeah, so the answer is A, reduced latency. So, you must have seen that the latency is in an availability zone is less than 2 milliseconds apart, and within that it can be less than 1 milliseconds apart as well. And within a region, like if you connect to various, if there are no availability, if, one region can have like several availability zones, and if you connect like between each of those availability zones, there can be uh, like less than 2 milliseconds or less than like 1 millisecond difference, right? So if let's say it is simply like in one simple area, you know, you may just get, let's say in one region, let's say you have only one availability zone. If you're very far away from it, you may have a very high latency. So according to the text, why might a user prefer a site close to their nation or country for AWS services? Is it for A, lower pricing, B, better customer support, C, improved privacy and compliance enforcement, or D, enhanced network speed? Anyone have any responses?
So for better customer support.
Better customer support, why?
C or D.
D could be an
C and
option.
D both are, like, latency is also a factor, also compliance.
Yeah, yeah, yeah. Definitely. These are definitely important to answer. So one thing is customer support wasn't discussed in the slides actually in the lecture, right? So yeah, the customer support for India may not may not necessarily be sitting in India, right? So one thing is, see, because it wasn't discussed in detail, we cannot necessarily say B is the correct answer. See, so AWS, we don't know if it reveals whether its customer support is location dependent or not. But we know for sure that C and D is definitely location dependent, right? So enhanced network speed. For example, if you have a server in India, right? Okay, so if you have a server in India, and let's say you are accessing it from US, you will have much higher latency. And also, if your server is in India, so India's privacy laws and compliance enforcement uh, compliance enforcement systems will determine how whether your data is safe or not, right? So that is why C and D are accurate answers. Fine.
Oops.
I just add D also. Okay. So hmm okay, so let's look at this question. What is the purpose of AWS availability zones? Is it A, to increase network bandwidth, B, to ensure data encryption, C, to prevent single points of failure, or D, to optimize resource allocation?
See,
Huh. C. Any other responses? Any other? What is the purpose of AWS availability zones? Is it A, to increase network bandwidth, B, to ensure data encryption, C, to prevent single points of failure, or D, to optimize resource allocation? Okay, fine. So the answer is C, right? So if you have only one availability zone in a certain region, and if it fails, you may have to go to another region. So because of the new region, what we saw was these services may be location dependent, so that may lead to higher network speed, or that the privacy and the compliance enforcement may not be as strict as you would have desired in that specific region, right? So to make sure that the single points of failure are not there in a one region, you'll have multiple availability zones. And to optimize resource allocation, I don't want to say that is a correct answer, because see, you are the person who decides which availability zone you want to put your data in. You're one of the biggest deciders of that, right? So resource allocation is something that is done system side. So I wouldn't say that is the most appropriate answer. Okay, but it is definitely very appropriate to say to prevent single points of failure. So how are availability zones designed to handle failures? A, by replicating data in multiple locations. B, by increasing network security. C, by minimizing latency. Or D, by enhancing computational power.
Answer yes, sir.
Hmm. Yes, A is the correct answer. Any it is not very challenging to see that B, C, and D are the wrong answers. Well, not exactly. B is not exactly wrong, right? But we don't. Once again, it's not really been discussed. Whether creating more availability zones will increase network security or not. So that policy in AWS has not been made clear. So that is why I don't want to say that B is the correct answer. So minimizing latency, that does not really help reduce failures. That just means that you will get your data, whatever you need, faster. Enhancing computational power. Once again, to enhance computational power, you need better, chips or better hardware or something like that. It is not really something that comes by virtue of having more availability zones. So yes, so 2A is the correct answer. By replicating data uh, in multiple locations. So how are availability zones basically separated according to the text? By using virtual networks, by geographical distance, by network protocols, or D by server configurations.
Answer A.
Answer
A.
A. So
BB.
B is the correct answer.
Oh,
So hmm. So why not virtual network? So in one availability zone, right, you can put multiple, you can create multiple virtual networks right inside one availability zone. So so let's say there was a single, let's say everything inside one availability zone was inside one network. Everything was inside one virtual network in another availability zone. So what I think is, it kind of, see, you wouldn't want two clients who have no relation with each other to put their devices on the same network, right? Or at least on their virtual network. So so that is why you can say that you cannot really exactly separate availability zones by virtual network exactly. So the answer is B, by geographical distance. This is also very simple. What is the primary purpose of edge locations in AWS? Is it A, data replication, B, lowering network bandwidth, C, delivering content with low latency, enhancing computational power?
answer B and C.
Uh, why B? So no, so B is not exactly the right answer, right? So edge location, what do they do? So if you have some data, okay, can you say B? To some extent, yeah, you could say, because the data is closer to you, right? Lowering network bandwidth. Let me think about it. So I mean, yeah, you maybe if you could, yeah, of course the benefits of edge locations are kind of similar to that of edge computing, right? So they, in edge computing, bandwidth is improved because you don't send data like very far away. So even here in this edge location, you send data only close to the edge device. Only the you send data close to only the some specific edge location. You send requests only close to some specific edge location. So you could say that network bandwidth is reduced. Okay. So but definitely C is also a right answer. B and C would be the right answers. Okay. So let's look at the fourth one. So which AWS services support the global network of edge locations? So is it Route 53 and CloudFront, S3 and EC2, Lambda and DynamoDB, or RDS and Redshift?
Answer E.
Sorry?
A, sir.
A, okay. Any other responses? Route 53 and CloudFront, S3 and EC2, Lambda and DynamoDB, or RDS and Redshift? So yes, so the answer is 4A, Route 53 and CloudFront. So Route 53 is what is enabling the networking, and CloudFront is what is supporting all these edge locations. S3 is just storage, EC2 just provides virtual machines, Lambda is for function invocation, DynamoDB kind of provides an unstructured database system. So these combinations don't really help, don't directly help at least in providing the global network of edge locations. RDS and Redshift are also, one is they have different purposes. Mm, okay, fine. So let's look at this question. So when launching an AWS EC2 instance, what does the customer need to specify? Is it A, network configuration, B, availability zone, C, security group, or D, instance type?
Yes, sir.
Just A. Any other responses?
DMs, DNDs needed.
Huh. Then?
DND.
Hmm. Then? Any other? So have you all studied security groups? I'm sorry, I don't remember. Has security groups been discussed in the course in AWS? Okay, so fine. I don't think security groups have been discussed, but you have to specify that also actually. Okay, when you if you actually practically go into AWS and you have an EC2 instance, you need to specify all of these like network configuration, which means, well, actually this is kind of default generally what I have seen, but A, B, C, and D, all these you have to specify. Okay, just ignore this. Just delete this otherwise. So how are availability zones connected in AWS? Is it sorry? Is it
So sorry for the interruption. So what is the answer for the previous question?
everything? A B C D.
ABC.
A B C D.
All.
Yeah.
Okay. Okay.
So how are availability zones connected in AWS? Through virtual private networks via private AWS fiber links, using public internet connections, or through satellite communication. So okay, so the answer is B. Okay, via private AWS fiber links. So of course all AWS. This is not the right answer exactly, because all the availability zones may not necessarily be on the same private networks, and these connections need not be based directly on the be directly public, like, because even though they are available to you via some public internet, it's not necessarily always true. Satellite also has not been discussed. So what is the purpose of having more than one data center within an availability zone? Right, to increase network latency, to improve data encryption, to ensure high availability, or to reduce network bandwidth. Okay. Does anyone have any responses? What is the purpose of having more than one data center within an availability zone? Is it A, to increase network latency, B, to improve data encryption, C, to ensure high availability, or D, to reduce network bandwidth?
Answer C, sir.
Yeah, to ensure high availability. So why is that? Because if you have multiple data centers, you can also replicate your data in several places. So because of that, you can make sure that. And also one more thing is you can and so because of that, you'll be able to query multiple areas. So if one area is down, another will be up. So what is the maximum latency provided by data centers within an availability zone? As mentioned in the text, is it less than 1 millisecond, 1 millisecond, more than 1, or exactly 1?
Answer A.
Answer A. Yes, it is less than 1 millisecond. So let's look at your notes. So data centers in availability zones are less than a quarter of a millisecond apart, right? So because of that, the answer is less than 1 millisecond. So data centers in one availability zone are less than quarter of a millisecond apart. Oh, sorry. So according to the text, which aspects of security are the responsibility of AWS? Okay. So is it the client side data encryption? Is it server side data encryption? Is it operating system, or is it the network firewall? So, is there any confusion here? Okay, let's look at your notes again. Right, so these two parts, right? All these two, uh, so these two are what is AWS responsible for? Okay, so the client side data encryption and the server side data encryption. So of these, like the security in these two aspects, like belong to the customers. So if you, so over here the okay. But as far as like operating system, network, and firewall is concerned, like, okay, so these two, of course, these two belong to the customer. Uh, but okay, so networking would be the okay. Let's skip this answer for now. Okay, the option should be networking. Okay, so uh, so AWS is responsible for networking. networking on the side of the cloud. I'm sorry, there was a mistake over here. Fine. So the answer is D. Okay. Hope that is clear. So which part of the AWS infrastructure is responsible for security? Is it A, AWS global infrastructure, B, edge locations, C, customer applications, or D, foundational services? I'm very sorry about that. Now let's look at it. What part of the infrastructure is AWS responsible for securing? Is it A, AWS global infrastructure, B, edge locations, C, customer applications, or D, foundational services? Okay, so the answer is 2A, is AWS global infrastructure. So if you look at your notes, AWS global infrastructure, so all these things AWS is responsible for securing. Okay, fine. So which of the following is not listed as a customer responsibility for security in the cloud? Is it A, network traffic protection, B, identity and access management, C, client side data encryption, or D, foundation services, sorry. Which of the following is not listed as a customer responsibility for security in the cloud? Is it A, network traffic protection, identity and access management, C, client side data encryption, or D, foundation services? Okay, so the answer is D, foundation services. So let's look at your notes. The AWS foundation services over here is responsible for security. Is present over here. AWS is responsible for securing this side. Okay. So what is the networking service provided by AWS known as? Is it A, virtual network service, network cloud service, virtual private cloud, or cloud networking solution? Any responses? Are there any responses for this? Okay, it's getting late. Fine. I think I'll end the session now. So the answer for one is C, virtual private cloud. I will make these recordings available to you. Okay, fine. Okay, thank you for coming. I will end the call now.